guys, today we're going to do physics class, and in this physics class we're going to do our first chapter, units and measurement. And what we're going to learn in units and measurement? Physics significant figures. So before we start the lesson, please subscribe, share, like and comment if you do have any doubts. Now let's get started. So first thing we should ask is, what are significant figures? Where do they come from, and how do we use this in our life or in the subject physics? So significant figures are figures which is there in decimal forms, which is similar to mathematics. Value of a physical quantity tells the number of digits in which we have confidence. Larger the number of significant figures obtained in measurement, greater is the accuracy of the measurement. The reverse also, the reverse is also true. Let's take it for example. All non-zero digits like 1, 2, 3. What are they? They are significant. But one thing is that if the zero is between the non-zero digits, then it is considered significant. If it's not there, not between them, then no, it is not considered as a significant digit. So let's take it for another example. Let's take another example. 4.23. In this, how many significant figures can you see? 3, right? Why? 1, 2, 3. These 3 are known as the significant figures. Or another example, 1, 1, 1. These 3 is also a significant figure. If a point is there, then this also will have to be considered as a significant figure. There is a rule that states that zeros which are in the right direction are considered as significant figures, but those which are here, not considered. But here, yes, it is considered as a significant figure. When is the zero considered as a significant figure? When, let's say, 1.01. This zero will be considered significant. Why? Because it is between two non-digits. Two non-zero digits. Non-zero digits. So you get the brief idea. 1.101. How many significant digits are there? We have here 4. What about here? We have here also 4. Now let's take another example. 0.0001. Now tell me how many significant figures are here. There's about 4, right? This is not considered as a significant figure. Because what do they say? Those which are in the right direction are considered as a significant figure. That only applies for zeros. Rest non-zero digits can be considered significant. In problems in physics, they'll tell when to stop how many significant figures must be there in the calculation. That will be learning in the next session. Now, we get a brief idea. Let's take a summary. What are significant figures? Figures which will what are significant figures? Significant figures in the measured value of a physical quantity that tells the number of digits to which we have confidence. Larger the number of significant figures obtained in measurement, greater is the accuracy of the measurement. Which is the reverse, which if the accuracy of the measurement is also true, the greater is it, then the rest also is also true. Then next we have the exponential figures. What are they? Let's say example 1.23 0.00123. To make it short, we can do this, no? 1.23 into 10 raised to the power -3. So how many significant figures are there? But in this case, we will be taking this as a significant. If we don't take the exponential, that is the 10 raised to minus 3 or minus 2, we don't take them as the significant figure. So not considered as a significant figure. Whereas like 1.23 or the non-zero digits, which is in decimal or non-decimal, into that 10 raised to something, those 10 raised to minus something or the 10 raised to anything, the exponentials, they are not considered significant. Only the non-zero digits or 1.01, anything which comes here, they are considered as a significant figure. Now we'll move on to rounding of numbers. So rounding of numbers, how do we round off these numbers, we shall see. Here in rounding of numbers we have a few rules. So what are these rules? Let's find out. Rule number 1, if the digit is less than 5, preceding digit is left unchanged. Rule number 2, if digit is greater or more than 5, the preceding digit is raised or plus 1. If digit, the rule number 3, if digit to be dropped, okay, is going up, to be dropped is 5 followed by digits other than 0, okay, like numbers like 1, 2, 3, so on, except 0, then the preceding is raised by 1. If the digit to be dropped is 5 or 5 followed by 0, if there is 0 behind it, preceding is left unchanged if it is even. Rule number 5, the same only, but if it is odd, if the digit is odd in front, then the preceding digit is raised by 1. See, if the front is an odd number, okay, in front of 5, then it will be added by 1. So we'll go through the rules once more. The rule number 1, if the digit is smaller than 5, the preceding digit is left unchanged. So let's say, for example, 1.32. This is less than 5, no? 2. So it will be kept as 1.3. This is the significant figure, rounding off. Next, if the digit is greater than 5, for that example, let's take it 3.48. Now you can see that this is greater than 5. So what if it's greater than 5? The preceding is raised by 1, which means this will be 3.5. This is a significant figure. So what is it? The digit which if it is smaller than 5, we leave it unchanged. Just keep it there. If if it's more than 5, then you have to feed 1. Next, if the digit to be dropped, okay, if the digit is about to go, the one you want to leave is 5 followed by digits other than 0, then the preceding is raised by 1. Okay, let's take it for example 1.253. Do you see any zeros here? No, right? So this is a non-zero digit. So it is said followed by digits other than 0. Then the preceding is raised by 1. If this is there and this one, this will be 1.3. See? If it's not 0 anything, then the front here, this one will have a plus 1. So it will be 1.3. So got it here? Now rule number 4. If the digit to be dropped is 5 or 5 followed by 0, okay. In the other case, it is only by other digits. But this one, it can be followed by 0. If it is the preceding will be left unchanged if it is even. Okay, if it is even, like 2, 4, 6, right? I'll show you an example. Let's say 5.4450. Okay, what is this? Is this odd or even? This 4? No, right? It's even, right? So this is even, and this is a 0 digit. So this 5, it will give 1. So 5.5. Sorry, this is for the rule 5. This will be left unchanged. Okay. If the numbers are even or the preceding digit is even, then leave it unchanged. But if it's an odd number, okay, if it's odd, that is, if the digit to be dropped is 5 or 5 followed by 0, the preceding will be raised by 1 if it is odd. So I should give you an example. 81.357. Okay. Now how do we round off this figure? This 5 is there and this is an odd number, no? So 81.4. This is your significant figure. So got the idea? Rule number 1 states that if the digit is less than 5, preceding digit is left unchanged. If it is more than 5, then the preceding is raised by 1. The third one, if the digit dropped is 5 followed by other digits except 0, then the preceding is raised by 1. The fourth and fifth, that they both have the digits which is to be dropped is 5 or 5 followed by 0. But the thing is, rule number 4, the preceding will be left unchanged if it is even. The fifth, last one, if it is odd. If it is odd, it will be added. It will be having one more apple or something. So it will have 1. 4, it won't eat anything. So just keep the silent. He doesn't want to eat anything. He's already full. So even, don't give, left unchanged, leave him alone. Fifth one, if it is odd, then give him some food. That is only 1. Got the idea? Now we'll be doing here, taking into account the significant figures. What is the value of 9.99 meter plus 0.0099 meter? So pause the video and try to solve it out. 9.99 plus 0.099. This is actually, you can add them. How do you do? 9.99 0.0099. This is actually simple, right? You will get 9.999. But what about significant figures? They said to take into account the significant figures. So how do you get the significant figures? By rounding up. Most important thing is when you try to add, multiply anything, first you have to find the least significant figures. What are the least significant figures? Let's say a digit like this, the significant figures, right? The least of it, the smallest significant figures, the smallest number of those figures, that you will take into account, and the final answer, that many significant figures you can put. So 9.99, right? So how do you round this up? We already know that if the digit is greater than 5, then the preceding digit, like say this digit, will be added, right? So what will happen if it's added? It will be 0.10. Na? This is the answer. 10.00. This has 4 significant figures. Since this is a 9 we took, and if we just put this 1, na? So 0.9. The reason why it's for having 4 significant figures is because you see these 2, right? We have 3 here, but 1 will come here, right? So 10.00 meter, okay? You have to write the unit, meter. So this is the final answer of this question. Now moving on to the next. The reason why we put as 4 significant figures is because that in this figure, this digit, you can see there are 3 significant figures as I told before. But what matters the most, or what is the most important, is the significant figures after the decimal point, here on the right side. You can see there are here 2 significant figures, but here there are 4. So the final answer should have only 2 significant figures here. So that's why we have 0, 0. What have you learned? Zeros in the right direction can be considered as the significant figures. So that is why it is 10.00. Instead of 3 significant figures, we have 4 significant figures. As I told, because of the decimal places.